Hi everyone. So if you were in the Zoom today, you should have already seen this lesson. But for those of you that weren't able to or want to review one more time, here is just a little bit of an overview about the getting ready practice that was posted, just to review a little bit of solving equations and equations of lines. So when we solve an equation, our goal is to always get x by itself or isolate whatever variable we're looking for. What does x equal? And normally, like A and B examples here for number one, if these things are isolated, if each side can't be combined any further, then we can just start with reverse order of operations, move things around, divide, and get our answer for each, right? What I want to start with is to focus on part C, because this is where a lot of people tend to start to struggle. And notice in part C that we have 6x and negative 2x on that left-hand side of our equation, okay? We can combine those, since they're on the same side of the equation, to be 4x, because 6x minus 2x is 4x. And then we're also going to want to do the same thing with our remaining constants here, 8, negative 3, and positive 15, because 8 minus 3 plus 15 is 20, okay? Now we have everything condensed down. We can't combine the 4x plus 20 any farther. So what we're going to have to do is start using our reverse order of operations to move across our equal sign, right? So what we can do is we can subtract 20 from both sides, right? So that we undo that addition there. And what we have still is 4x on the left-hand side and 160 then on the right-hand side. Now from there, to undo the multiplication that's between the 4 and the x, we don't usually put the multiplication sign, but we know it's there. We use division to finally get that x value by itself and get our final answer here of 40, okay? Now, a couple other things that are important to keep in mind as we're doing this. If you have a coefficient out front, like we do in D and E in front of the parentheses, a reminder you need to distribute to each piece of the parentheses. So in this case, let's focus on E. We have 3 halves here. We need to distribute that to the 4x and the 6 before we can continue solving. Now, a reminder with your calculators, especially those of you who haven't used your graphing calculators in a while, to type a fraction in, like 3 halves, you're just going to do 3 divided by 2, because all a fraction is division, okay? And then we're going to multiply that by 4, so we would have 6x, and then multiply by 6 to distribute to the other piece, and we have 9. So when we distribute this through, we have 6x plus 9 equals negative 3. And again, everything is condensed on both sides, so we can start moving this across using that reverse order of operations. So we have 6x equals negative 3 minus 9, which is negative 12. And then divide that by that 6, we end up with negative 2. Okay. Now, the next piece of this is focusing on, I would say, probably the other biggest thing, especially in Unit 1, which is our lovely pal slope and equations of lines, okay? So just to side note a little bit for a second here, we have y equals mx plus b is our slope intercept, not internet, form of an equation, right? Y equals mx plus b. And hopefully this is kind of jarring some things in your memory of long ago of algebra. The m here stands for slope, okay? AKA your rise over your run, change in y over change in x, however you think of that, okay? And for slope, we have my good friend, Mr. Slopeman, here. And when you are decreasing, moving left to right, that's going to be negative slope. Increasing left to right is positive slope. If you have a vertical line, it's undefined slopes, looks like a U in his nose. And if you have a horizontal line, it's 0 slope. Okay, that's Mr. Slopeman. So those are a couple facts there. And then the other important part of our equation here is B. And what B stands for is our y-intercept. So if we have a graph, the y-intercept is on this y-axis. Where are we touching the y-intercept or the y-axis? That's our y-intercept, okay? And it's always going to be listed as a point. If you want to think of it this way, you're not moving left or right at all. And what B value or y coordinate are you at? Okay. All right, so back to where we were at here. If we scroll down to number 2. All right, notice for number 2, they gave us the equation of our line. Okay, and what they want us to do is to graph it and then state the x-intercept and our y-intercept. Okay, so the first piece here is that they gave us that y-intercept is at -6, aka right here on our graph at 0, -6. Okay, that's our y-intercept. We're at -6. And they also gave us that the slope is 3, aka 3/1, which means we are rising 3 and running 1 each time. So we're 1, 2, 3, run 1. Rise 3, run 1. Rise 3, run 1. Or you could go back to the starting point, down 3 to the left 1 to kind of continue that pattern for our lovely line. Oops. For our lovely line. Okay, so there's our graph. Now we stated the y-intercept up above here. What we haven't stated yet then is the x-intercept. And just like where does the y-intercept touch the y-axis, our x-intercept is where did we touch the x-axis. In this case, when we were rising and running, we touched the x-axis at 2, 0. And we move to the right 2 and then 0. So what you'll notice is anytime you have an intercept, for y-intercept, your x value is always 0. For an x-intercept, your y value is always 0. Great to see those points. Now, number 3 is basically the opposite of number 2 in that this time they gave us the picture and they want us to write the equation of the line. So again, our equation of the line, y equals mx plus b, but we need to come up with what the heck is m and what the heck is b, right? Now, b, I'm not going to lie to you, is kind of the easier one to find visually because we just want to look on our y-axis. Where are we touching? Well, we are touching the y-axis at 0, 3, aka our b value is 3. And then the next piece of this is what is our slope? Well, we talked about with Mr. Slope Man, if you are decreasing, it is a negative slope. So right away we know this slope here is going to be negative. And then notice we are going down 1 to the right 1. So 1 down, 1 over, -1 is going to be our slope. Okay, so here's our equation of that line. Now, you might also be noticing, okay, well, -1, we don't have to write that in front. You could just write this as -x plus 3. Either way, both of these are acceptable, correct answers. All right, finally, last piece of this, okay, is talking about the slope, looking at it both graphically and using the slope formula. So notice here they're giving us 2 points, 5, -3. I'm going to plot that one, and then 7, +3. And this is my line, right? Now, graphically, what you are going to notice, again, with slope, is that it is equal to the rise over the run. Okay? So to get from -3 up to 3, we had to rise 1, 2, 3, 4, 5, 6 units, and we had to run to the right 2 units. Oops, that's a bit of a typo because of my cursor. So 2. So when we reduce that, really our slope is we are rising 3, right? Rising 3, running 1, and it would give us that same picture, right? It's almost like we could put another piece on here. Okay, so our slope is 3. So this is checking it graphically, just using that picture. If we are going to use the slope formula, though, again, one way we like to talk about slope is being the change in y over the change in x, aka subtract your 2 y values, subtract your 2 x values, okay? So if I look here, my first y value is -3. My second y value is +3. So I'm going to subtract -3 minus 3. And my x values are 5 and 7. So I'm going to subtract those. So I get a total of -6 over -2. A negative divided by a negative is a positive. And again, we got 3. Now you may be questioning, okay, Missy, check the formula says y2 minus y1, x2 minus x1. Why did you do the opposite of that? Well, the thing is with slope, it doesn't matter which point you call x1 and y1, either these two or these two, you're going to get the same answer either way. So I'm going to expand for a second so we can kind of look at this again. So let's say I switched up the order. And let's say instead of starting with this ordered pair, we're going to start this time with 7, 3. So again, it's still y minus y over x minus x. So we have 3, this y value, minus the second one, which is -3. And then we have 7 minus 5. Well, a negative minus a negative is actually addition. And then 7 minus 5 is 2. And so again, we got 3. Either way we did it, it's simplified to be that same value. Okay. I usually like to start left to right, so do this y minus this y, this x minus this x, to each their own. Okay. Hopefully that helps review a little bit of the algebra, and I'll see you guys later.